So what's the quickest way for us to do this? And sometimes, as I've shared with you before, learning what you can accurately eliminate is just as important initially in figuring out what the final answer is. So what I see here is we are looking at the graph of g of theta, and I can see that at 0 the output value is 1. When you want to think along this line, when we're here at 0, we get an output value of 1. So let's just watch this really quick. If I'm going to see what I can eliminate with just this knowledge. If I plug in 0, I know 2 times 0 is 0. And so I'm just using my knowledge of the unit circle to see what I can do. What is the cosine at 0? So here's the unit circle, and here's 0, and this cosine is 1, 0. So this portion is 1. The cosine of 0 evaluates to equal 1. 2 times 1 is 2. 2 plus 1 is 3. So the output value here would be 3, but I don't want an output value of 3. I can see the y value is 1, so the output value is 1. Eliminated. Let's try this one. When I plug in 0, 0 minus pi over 2 is simply negative pi over 2. But notice there's a 2 up front, so when I multiply, I get negative 2 pi over 2. And those 2 simplify, and I have just negative pi. So I want to know what, if I move this down just a little bit more, I want to know here, again, we're just seeing what can we eliminate. I want to know what is the sign at negative pi. So let me draw the circle. Negative pi, I'm going to reverse it, it's right here. The sign, well, the ordered pair here is negative 1, 0, and the sign is 0. So this portion is 0, 2 times 0 is 0. 0 plus 1 is 1. This is a possibility of being an answer. Let's go to the next one. 0 minus pi would be negative pi, and 2 times negative pi is negative 2 pi. Okay, so negative 2 pi, we have to reverse, and that's 1 revolution. We're stopping right here at 1, 0. I want to know what is the cosine. The cosine is 1. 2 times 1 is 2. 2 plus 1 is 3. I want 1, not 3. Okay, let's go to the next one. Plugging in 0. 0 minus 3 pi over 2 is negative 3 pi over 2. We have that 2 up front. The 2's are going to be simplified to 1, and I have negative 3 pi. Okay, so I'm doing the opposite. We're going to go, there's negative 1 pi, negative 2 pi, negative 3 pi. So this is where I land. This is negative 1, 0. I want to know the sign. It's 0. So this portion, when I substitute an input value of 0, gives me 0. 0 times negative 2 is 0, and 0 plus 1. So I have 2 choices right now. And now I'm going to go back to using my understanding of graphing and translate horizontal translations or shifts to be able to accurately choose the answer. So remember, this is going to lie to us. So this is actually going to move to the right pi over 2. So if I reverse this, so it's been moved to the right pi over 2. This is supposed to mimic this. If it's been moved to the right pi over 2, let's switch it back. So if I take this and move this back, it's like I cut this out, I literally pick it up, and I line it up on the y-axis. This is what it would look like. Okay, this is what it would look like. And this is, we can see this is the midline y equals 1. All right, but here's the problem. This says we have an amplitude 2. Okay, we have an amplitude 2. But the positive value says that this sine function should go up first and then down. And we can see that it's actually been reflected across this midline. So this should have been a negative. Cancel this out. Let's come over to this last one. I have one choice, so I'm feeling really confident, but let's go ahead and do this anyways. So this negative, remember we go in the opposite direction. So we're going to take it, it's been shifted to the right, opposite of what you think, a distance of pi over 2. So I'm going to go to pi over 2. It's like I'm going to take this, I'm going to cut out everything to the right, and I'm going to reposition it on the y-axis. When it repositions, we can see that it would look like this. Okay? And now this is matching up. We can see we have an amplitude of 2, and we can also see it's reflecting across this midline. So the correct answer is D.